Okay, folks, so we're pretty much at a point where we can start converting our ERD model over to a relational data model. So up to this point, we've been doing strictly design work and designing our database and what the system is going to look like. So we're at a point now that we can start converting that into a relational design. So, of course, that relational design is going to mean that that each of our relations or entities must have relationships with other entities. So, if you look at the displays that I have here, the images on the left side, I have an ERD model that's of a rather complex system compared to what we've been working on thus far. And as you can see, we have all the entities identified, and to include the entity name, which again is a singular noun. And then we have the primary keys that are identified in each of those entities, as well as the relationships between those entities. And this is going to be very, very important as we start moving to that relational data model. So, for instance, as you can see between product line and product, we have a one-to-many relationship. And both ends of these, you'll also notice, are mandatory. So in other words, a product line must have products, and each product must be in a product line. So the primary key, as we start developing these relationships, the primary key is going to establish that relationship by becoming a foreign key in the related relation. So if we look at the SQL that we have over on the right side, you'll see that we have we're creating 4 different tables. We're creating customer table, the order table, product table, and the order line table. So those are effectively these 4 tables here on the right side of this ERD. So we have in the customer table, we have a customer ID, and we've identified that here. And then we have the customer name, customer address, city and state, postal code. And then we identify the primary key as a constraint. And there are a few ways to identify primary keys and foreign keys, but this is one of those ways. And of course, that attribute has to be a non-null attribute. Now, technically, if you identify that as a primary key, it's automatically going to make that not null. But in any event, so we also create the order table, which is just below that, which has an order ID, which is the primary key, which is defined right down here as a constraint. And then you'll notice that that within that order table, the creation of that order table, we're also creating a foreign key that goes back to the customer ID up in the customer table. So, of course, we have to identify the customer ID as an attribute and then define that attribute as a foreign key that references the customer table. So, and that establishes that relationship between the customer table and the order table. And now you'll notice again that the primary key, customer ID, has become, which is on the one side of that relationship, becomes the foreign key in the related table, in the order table, which is on the many side. So again, the primary key is on the one side, the foreign key is on the many side. And to create our product table, it's the same thing. We have a product ID, which is our primary key, of course is not null, and we define that constraint as the product PK as the primary key. And then finally, we create the order line table. And we have a couple of foreign keys that are being identified: the order ID, the product ID, and we'll have to identify those in our constraints down below. And of course, every table that we create is going to have to have a primary key. So we make sure that we do that, and then establish the foreign keys, which reference the order table and the product table. So again, this is what we need to do to establish those relationships between those entities. Now, what it's really easy to do is to just create the tables without those constraints, without identifying the primary key, or more importantly, without identifying the foreign keys that reference back to those related tables. And if we don't establish that relationship between those tables, it's not a referential database. It's just a group of flat files that have data in them, or have the potential to have data in them. So it's really important that we understand that. So kind of get your brain wrapped around that. And next week we're going to start writing this code. So another thing I wanted to mention is so last week we were talking about the enhanced entity relation, or the EER model. So let's take a look at that real quick. So we're probably not going to see this in this class, but there are ways to convert this this type of supertype subtype structure into our relational model. So, and there are a few ways that we can do this. The first way, of course, is that we can convert each of those entities into tables, into relations, and give them of course, the employee is going to have a primary key of employee number, and then we're going to have to give each subtype the same primary key. So that basically kind of defeats the purpose of having those subtypes inherit those the attributes from the supertype. So that in having more tables in your system really creates a lot of overhead in the system, and a lot more processing requirements and the like. So we really want to avoid that as much as possible. So another option is that we can create entities just for the subtypes, and that's certainly an alternative. but again, we have more tables than we probably really need. So the third option is to just create one entity that that encapsulates all of the attributes for all of those subtypes. So, and that's not too difficult to do. We can have an employee number, or an employee entity with the employee number, employee name, address, and so on and so forth, and then also include the hourly rate, and have an attribute for an annual salary, stock option, and so on and so forth. And if this is a disjointed attribute, it's pretty easy, because you can just have an attribute called job or employee type, and then in that attribute you can have it listed as hourly, salary, or consultant. Now, a problem that we have with this type of structure is if this disjointness was actually overlapping. So an employee can be two or more of the three below. Now, obviously, that's not going to work in this model, but then in order to do that, then we're going to have the different job types and have a Boolean type value in there. So it's either yes or no for those different job types, and that becomes a little messy, but that saves on our own resources and the like. So give that some thought. Again, I don't think that we're going to need to do that for any of our projects. You shouldn't have to do that, but just keep that in mind. So we need to start looking at some of the other aspects of an Oracle database. So briefly, we've discussed some different views in our database. Now, of course, we can create our own views, and that happens very, very often. And the cool thing about the views is that it actually protects the database from users accessing the tables directly. So now these views typically are they appear to be tables themselves when actually they are references to other tables, and in many cases they access several tables at once. So in this view, you'll see that that we have 6 different fields that that actually refer back to 3 different tables within the database, and when a DBA writes queries against what appears to be tables, those are typically views, but it's they're running those queries against the fields in those views. And again, like I said, it's just one aspect of that is that it's a security measure to protect the active database against direct access from users, whether it's users through an online source, a web source, or DBAs that are running queries against the database. And finally, we have a data dictionary. So the data dictionary is very, very important to DBAs, and if you guys start moving in that direction, you'll start becoming very familiar with that data dictionary and some of the tables that are available in that data dictionary. So of course, the data dictionary stores metadata about that table. I'm sorry, about the database, and of course, metadata is data about data. So that just gives you information about the structure and the tables. All the details that are available about that database are going to be accessible in the data dictionary. Now, of course, a user or DBA or no one else can alter the information within the database. However, those tables can be queried. Most of the tables can be queried. There are some that just can't be seen. And there are some examples of some tables or views rather that are going to be available in the Oracle Data Dictionary. And this week we actually covered several views that are available in that data dictionary. So, and there are lots and lots of them, and they grow with every new version of the Oracle database. So that's pretty much all I have for this week. Pretty simple stuff. If you haven't gotten your Nova account set up yet, please go ahead and do that and start moving that using Core FTP or some other FTP utility that's available out there. There are lots of them. Start pushing that SQL file that I provided you out to your Nova database. Or I'm sorry, your Nova account. Log into your Oracle account and run that script and make sure that it creates a database for you. And let me know if you have any questions.